In talking about the challenges that we have to overcome in applying optical flame detection to large commercial and military aircraft hangars, it's worth taking a moment and looking at what we're actually seeing on the screen right here. In that this purple shape that we're seeing is a representation of the coverage envelope or the detection envelope of a typical multispectrum IR or MSIR flame detector. And what we're seeing here is the three-dimensional field of view of a detector with about a 22.5 meter displayed range or effective range. And most of these things are advertised at 30 meters. That's an ideal test environment range. We derate to, in this case, about 22.5 meters to factor in the fact that these things usually do not work as well in the field as they do in the lab environment. Now, that's not to minimize the accomplishment that's represented by this. This is saying, because this is to a 40 kilowatt, roughly 1 foot by 1 foot test fire. So this is saying that this detector will pick up a 1 foot by 1 foot flame at a distance of 75 feet and respond and alarm in response to it in about 5 to 10 seconds. That's quite an accomplishment of technology and detection. But you will notice in the context of this 90 meter wide aircraft hangar, that 22 meter range begins to look a little bit puny. And so the question that we have to ask ourselves here is, can I get good coverage? Can I provide coverage at the ranges that I need to provide coverage to a space this big, a big open space like this, especially considering I am absolutely not going to be allowed to, say, put up a post in the middle of this hangar area and have a detector on post in the middle of the hangar. They're not going to let you do that, especially if this hangar is designed to house large jumbo jets. That's just not going to work, putting a post right here. So something to realize here being that the range of the detector is going to scale up and down with the inverse square law. So this detector can see fires out in the middle of this hangar, out beyond the range of this detection envelope. But a fire out here is going to have to be larger, and it's going to have to be bigger and putting out more heat and more light than a fire right here. And so because the fire is going to have to grow bigger, there's going to be a delay in response, and you're probably going to get more damage as a result because the fire is so far away from the detector. The other issue beyond just simple range in a aircraft hangar that you have to contend with is false alarm stimuli and false alarm sources, and unfortunately in an aircraft hangar there are a lot of them. You have very large hangar doors that can be quite wide, sometimes taking up an entire large wall of the hangar. That will oftentimes be open for large portions of the day, which means if you have any detectors back here facing out in this direction out the hangar doors, you are going to be able to see sunlight through the hangar doors if the sun is in the field of view. And sunlight can either desensitize the detectors and make them less effective, or it can put them into false alarm. If the hangar doors are facing out onto a runway, then there's the potential for jets that are getting ready to take off on the tarmac or on the runway setting off detectors because they will see the light or see the flame from the jets on the back end of the plane. If you are using UV, IR, or UV detectors inside the hangar, if you have windows or if those detectors can see outside the doors, you might get false alarms being triggered by lightning strikes outside of the hangar. A final approach that you'll sometimes see used to fight false alarm stimuli is, rather than go with a high sensitivity setting and increasing the range of the detector, but then also increasing the false alarm sensitivity of the detector, you will see some sites choose to switch to a low sensitivity setting and go the opposite direction with a smaller field of view bubble. This has the effect of making the detector less sensitive and therefore less likely to go into a false alarm or respond to something like sunlight or some other false alarm stimuli. But where we were having a hard time getting adequate coverage for a large hangar before with the medium sensitivity, it is virtually impossible when you're dealing with a large open hangar and you're using a low sensitivity setting. Now, if we were dealing with a very small maintenance hangar, like say if we have a maintenance hangar that's designed just to house 1 or 2 small fighter jets, and we choose to roll this out, this might actually have a chance of succeeding. And oftentimes, like the UFC criteria for military hangars will require that if aircraft can enter and leave the hangar under their own power, it is required or strongly suggested that the detectors be set in the low sensitivity setting to prevent false alarms from the aircraft engines. But while this can work with small, like single craft maintenance hangars, for larger hangars, there is just simply no way to provide good, rapid, effective coverage to the middle of the hangar if you only have, say, a 10 or 15 meter range on your detector. And because if this is to a 1 foot by 1 foot pan fire, when you extrapolate out with the inverse square law, by the time you get to the middle of the hangar, the fire here is going to be so large by the time this detector can respond to it that you might as well have waited for your smoke detector, I feel like. At that point, the detectors are simply no longer doing you any good because you've desensitized them so much and they are so short-sighted relative to the task that is in front of them. However, a lot of the foregoing discussion applies to multispectrum infrared detectors and UV detectors and UV-IR detectors. There is a different type of detector that we can use here, in that if we are looking at CCTV or visual detectors, these detectors use near-infrared sensitive cameras that are more spatially aware and can look not just for flicker frequency and the radiation frequencies of the flame, but they can also look for the shape of the fire and the variable shape of the side-on view of a liquid pool fire. These detectors also don't have multiple sensitivity settings. These detectors have a simple, single fixed sensitivity setting that's usually somewhere between the medium and the high sensitivity range for the MSIR detectors, where a MSIR detector in medium has an ideal range of 30 and in high it has an ideal range of 60 meters. The visual detectors will achieve usually about 45 to 60 meters of detection range for a comparably sized fire. So the interesting thing about the visual flame detectors and the fact that they will look for the shape of the flame is that the flames that come out of the back end of a jet and the flames that come out of, say, a propane welding torch are very regular, consistently shaped conical flames. They do not have variable flame shapes, generally speaking. And as a result, the visual detector is going to see that, and it's going to see a constant, steady shape. It's not going to see the variable size and shape of the flame that it's looking for in its signal processing algorithm. As a result, it is going to reject that as a genuine problematic fire, and it is not going to go into alarm. As a result of that, the visual flame detectors will give you very good false alarm immunity. They will not go into alarm in response to the aircraft engines, either in the hangar or out on the runway. They are not going to go into false alarm from lightning strikes. They are not going to go into false alarm from lightning strikes or the sunlight or anything else going on. They're not going to respond to arc welding. They're not going to respond to propane torches, but they will still give you range that is in line with the kind of range that you get from that high sensitivity MSIR detector that is going to be so exceptionally false alarm prone compared to even lower sensitivity settings of the same technology. Because of this, we at Micropack strongly recommend the use of visual flame detectors over other types of optical flame detectors for this application.